Off to a good start. I didn't bring any jokes for you guys today, except I did see one that popped up on IRC. Did you hear the one about the Linux car? It finished last. You know how impossible it is to find a decent driver for Linux hardware. It doesn't go well. I thought in Seattle it would have gone well. Anyway, for those of you who don't know who I am, my name is Bill Norton. In the early days, I used to chair NANOG, but since then I've gone to work at a company called Equinix for the last 8 years. There I have the official title of co-founder and chief technical liaison, which really means I spend about 90% of my time working with the customer base, the ISP peering coordinators. And over the last bunch of years, I've been trying to identify those internet operations topics that have not been documented before. You can find really good books on OSPF and on BGP. You can find details on the RFCs about the specs on how the packets are organized, but nobody had put together documents that describe from a practical perspective, how is peering actually done? What are the definitions that peering coordinators use to describe what peering is and how transit works and when they decide to peer and when they decide not to peer? So I went off to talking to some of the smartest people in the world, really, on this topic, and I collected what they said over lunches and dinners and lots of beers, and I wrote down what they said in the form of a white paper. Then over the next lunch or dinner, I'd walk the next set of folks through this white paper and said, this is what these other guys said. Does this seem about right? And folks would say, yeah, but you're forgetting there's a key component here, or here's a data point that you should cite, or here's a reference that would be valuable. So through a stepwise evolution process, I would eventually evolve this white paper through about 100 walkthroughs into something that represents the community mindset on a particular topic, like internet peering. It was interesting that, since I collected the information, I emailed it out freely, it started showing up on websites, and the white papers started showing up being taught at universities around the world. In fact, the Moscow Internet Exchange uses the Internet Service Providers and Peering white paper to describe how peering works and what it is and why the Moscow ISP should care. This is a very unexpected consequence of simply gathering this information and then propagating it back out to the community. So far there are 12 of these white papers out. They're freely available if you'd like any of these. Again, I collect the information from the community, so I view these as community documents, so they're freely available. And one of the things, again, I noticed that if you put this information out there in the community, up on the web, links get established, and they start rising up in the ratings by Google and the other search engines. So the observation here is, on the internet, everyone is a publisher. Now we start migrating to a new era when I met Colin Corbett from YouTube, and he was interested in talking about the peering stuff. So the first question I asked is, well, how much traffic are you currently sending to your transit providers? And he said 20 gigabits per second. Now to me, 20 gigabits per second is a big number. I come from the NSFnet days when the first backbone was a T1 and then upgraded to a massive 45 megabit per second link. And here's a company less than a year old that's already pushing 20 gigabits per second. More interesting than that is they're growing 20% per month. That means that if these guys are paying $10 per meg, then in a matter of maybe a year or so of operation, they'll be paying $1 million per month in transit fees. This is an enormous new wave of traffic that didn't exist a year or two ago. That's pretty impressive. But more impressive than that even is talking to Sequoia Capital. These guys tell me that when you have one YouTube that gets the kind of press and it gets that kind of press, you typically have between 30 and 60 additional competitors coming online that are pretty much doing the same type of thing, maybe with some twists and some wrinkles. So, you maximally might have 20 gigabits times another 30 or 50 competitors that are aiming to get up to that traffic level. I thought this was enormous. This was absolutely huge. There's another company called Dovetail based up in San Francisco. I went up and talked to those guys, and they're even doing high-def distribution of movies. They go to independent film producers who can't get the movies into the theaters and say, we can distribute your videos for free if they're of high enough quality. If we rate them as being worthy, we will distribute your videos for free. And that's high def. That's some pretty significant bandwidth, again, that wasn't distributed over the internet, say, a year or two ago. And then the final data point that got me interested in this video topic was going to a web conference that was run as a private meeting among the largest content providers in the world. And I shared with them the data I had collected so far, and we did an exercise that I call 2010. And the question I put to the group was, in 2010, we're all sitting in this room, and we're remarking about how amazing the previous 3 years have been. What do you think we would be saying? It's remarkable that in the last 3 years we see X. And we wrote down all the things that folks would say that we'd be talking about in 2010. Well, this is one of the data points that came out of that. They said in 2010 we're going to be saying it's remarkable that by bits, by volume, that 80 to 90% of all internet traffic is video. That's a pretty amazing prediction if that's true. That means the stuff we've been doing, all the static HTML stuff in the past years that we thought was enormous, is insignificant in comparison. Anyway, the whole point of this is not, you could challenge any one of these assumptions, but my point is that this is why I started looking at this new wave of traffic. We migrated from everyone being a publisher into everyone being a broadcaster. Take, for example, Desperate Housewives, which is now available to be downloaded to your iPod. If you do the math, and I got this information from Cringely, Desperate Housewives is a 210 megabyte file. This is a H.2.64 image. If you assume that they have 20 million viewers located in 10 million households, there's a possible market of downloading that single episode of Desperate Housewives of about 2.1 petabytes, which is enough to keep a 64 gigabit per second circuit active constantly for 3 days solid. Now think about this. That is just one TV show in an iPod format. It'll look good on your iPod, but it's a little teeny 320 by 200 or so image, and that's just for one show in low def. Now, let's say that you could get access to the previous episodes of Desperate Housewives and then multiply that times the different TV shows that will be cast across the net, and then even migrate that towards many different distributors of this content, and then go to high def. Again, the point is, this is potentially a huge wave, and that's why I started taking a look at the research. So the question I was asking the community was, how do people distribute video over the internet, and how much does it cost? So the way I approached the problem was I started developing some models with the peering coordinator community. Across the left-hand side are the various methods. The first one could simply buy commodity transit, and that's essentially a metered pipe to the internet, if you don't know. The alternative to that would be to buy services from a Limelight or an Akamai or a BitGravity, a CDN player. The third would be a hybrid of transit in multiple locations and peering traffic at those multiple locations. And then the fourth is a peer-to-peer distribution model. Across these different models, I applied a small, medium, and large load model, meaning what would it take to do a small load model defined as 10 videos being downloaded every 5 minutes. A medium load model is defined as, on average, 100 videos being downloaded every 5 minutes. And a large load model is defined as 1,000 videos being downloaded every 5 minutes. And the end result is a dollars per video matrix that you'll see coming up here for each one of these models. Now, for sake of time, I'm actually only going to be talking about the large load model, but the smaller and medium load model can also be explored in the paper, or I think, Vicki, did you put the spreadsheet, the actual end result spreadsheet up on the web? It's coming, okay. Okay. So note that I said about the demand curve that we're talking about an average of 5 minutes 10 videos every 5 minutes, or 100 videos or 1,000 videos being downloaded every 5 minutes. We all know, though, that the internet load tends to be much more sinusoidal, meaning that when people come home and turn on their computers and are using things, you tend to see much more of a peak for the residential marketplace and a much more of a trough when it gets towards 4 or 5 o'clock in the morning. So I tried to apply a sinusoidal curve to the demands that I had in the modeling. Jeff Turner from Intervideo, or Interstream, I keep forgetting which one of those he works for, tells me that there's a rule of thumb in the video industry that the mean to peak ratio is about 6.6 to 1, meaning that at the peak times you're going to see a much stronger load than for normal static web pages, which is generally about 2.5 or so to 1. Video traffic just has such a large volume and a large peakiness to it. The adult industry actually tells me that the peaks are substantially higher than 6.6 to 1, closer to 20 to 1, and substantially narrower, about a 1 hour period of time towards midnight that they engineer towards. And the point is that you need to, as a video service provider, engineer towards those peaks. You need to be able to have the server infrastructure to support those peaks and the network infrastructure to support those peaks. So if you do the math and you apply these numbers, you end up getting a peak for the small load model of about 2.6 gigs, and for the large load model, a peak of about 264 gigabits per second. But you're going to be paying transit fees in some of the models on the 95th percentile, which I'm assuming in this model to be about 4 times the average. So if you accept those assumptions, this is what the transit load model looks like. What you do is you end up getting about 264 servers to deliver up 264 gigabits per second. Each one of these servers has 2 gigi upstreams connecting to an aggregation switch. These aggregation switches will then in turn aggregate the traffic through 10 gig links up to a set of 4 routers. These 4 routers in turn will by transit 40 gigs a chunk for each router from 8 tier 1 ISPs. That gives you roughly about 320 gigabits per second. If you apply the math, then you see you're going to be paying 95th percentile on 160 gigabits per second. Again, that's the assumption where the 95th percentile roughly being 4 times the mean and the peak being roughly 6.6 times the mean. So 160 gigabits per second at $10 a meg is $1.6 million per month. Now the other thing that jumps right out at you is that $1.6 million per month dwarfs every other expense that's shown up on this spreadsheet. You could double the hardware, you could triple the hardware, you could double the staffing costs, and it does not make a material difference on the bottom line, which is down here, 20 cents per video. Maybe you'll increase it by a penny or 2 per video max. But it was interesting to me that it was that dominant of a cost. The transit fee is a remarkably large component of this cost. But this can't work. Who can tell me why? Not you, Patrick. Shout out an answer. There's a capacity issue. Absolutely right. In talking with the tier 1 ISPs, a bunch of them said, look, Bill, we can't satisfy the number of 10 gig requests that we're getting. We're in fact turning away 10 gig orders. Some of the tier 1 guys tell me that they have a queue of 40 or 50 10 gigabit per second transit orders that they cannot serve. Why? I asked them. Well, they said, first of all, you Equinix have run out of space and power. So I said, fine. Well, what would happen if we could wave our magic wands and free up the space and power, and you could go get those, whatever, CRS-1s or the Juniper 640s. I heard that the CRS-1s can go as high as requiring 6 times 60 amp feeds, Randy. So these are power monster machines. So what if I could make all that power and space available? Well, they said, well, that was just the first problem. The second problem is then I need to go and convince my finance guys that these this equipment that I've deployed and haven't paid for yet has to be replaced with equipment that costs at least 10 times more. And I need to make the business case for that to happen. I say, okay, maybe that might be a little bit of a challenge with today's transit prices, but what if you could make that happen? And he said, well, that's not that's just the first piece of it. Then I need to convince my peers to upgrade their infrastructure with a similar cost, because the traffic that I get video-wise is not all going to terminate on my network. Some of it's going to go to my peers. Okay, so what if you and your peers upgrade? Well, that's just at one pop. Then we need to upgrade the backbones to be able to handle all these big chunks of traffic back across the net. So all of our facilities need to be upgraded. And then that's not enough, because then you have the last mile issue. Can the last mile guys handle this increased large chunk of incremental traffic? All this is compounded by the fact that we don't have, we're talking about 10 gig transit orders, and we don't have a 40 gig standard for the backbone, and we don't really need the 40 gig, right? We need the 100 gig. Would people agree with that? To handle all these 10 gig transit orders. So we have a cascading set of failures that is limiting this, this market today. So the second model comes up quite a bit then. Why not just buy services from a CDN like an Akamai or a Limelight or one of those guys? And the financial modeling is interesting. If you look again at that top line number, what we've effectively done by outsourcing to one of the CDNs is we've increased that top line number, which is the largest component of the other infrastructure. And we've effectively decreased the cost of the server and the staffing costs. Because, if you outsource to a CDN, they can take care of everything for you. You don't really need to have a whole lot of server hardware, and your network infrastructure needs to handle pretty much just one or a couple of copies of that data out to the CDN. So you've increased maximally, well, not maximally, you've increased that top line number while decreasing the stuff that was insignificant. And you end up with a slightly higher cost. The third model is the build out to a bunch of exchange points and buy transit in each exchange point, but peer away about 25% of your traffic. The nice thing about this model is that you've effectively taken that top line number and reduced it by 25%. So instead of being $1.6 million per month, you're down to $1.2 million per month, a substantial savings. But you do need to increase the number of staff. You need to increase the amount of hardware. In the modeling, I'm assuming you take the first model with 264 servers and you duplicate that across 3 locations, the entire infrastructure. I'm assuming that you can operate any single one of those and support the load if that's possible. So you reduce that top line number and increase those other relatively insignificant numbers, and you end up with a lower cost. But here's where the magic happens. I didn't really fully appreciate the peer-to-peer stuff. I think it was Todd Underwood who said, hey, take a look at this company called PP Live based out of China. They actually do peer-to-peer video distribution. And I thought, there's no way that can work. I downloaded the client and tried it out. It actually worked. It was pretty cool. But more impressive was Dovetail. Again, Dovetail, the San Francisco company that goes to independent movie producers and says, you can't get those videos out across the net, those high-def videos. I'm sorry, you can't get them to movie theaters, but we will take the high-quality ones and distribute them across the net for free for you. At the time, last year, they had roughly 50,000 clients. I don't know what the number is now. But I asked the guy, so for Dovetail, what do you pay in transit fees? What's your transit rate? And he said, oh, I think we're paying roughly $60 a meg. And I said, well, how many megs does it take to do this video stuff? And he said, maybe 3, 4 megabit per second. And it's all about how the peer-to-peer stuff works. Once you get a highly interesting piece of content and it gets downloaded to the clients, each of these clients then becomes the seed for the other clients that eventually want to get that movie. And once Dovetail builds up enough of a buffer, you can start watching that movie. You do a netstat on your PC and you see it is in fact pulling pieces of the video from Israel, from Portugal, from Peru, from parts of Russia and so forth, and assembling that in the progressive buffer in front of what you're watching. It's pretty cool, and it actually does work. So in doing the modeling here, if we assume that these guys are, let's give them 100 megabit per second of transit, and he's paying $50 a meg, that still ends up being, for this large load model, a small fraction of a penny per video for downloading. And this is from the video service provider's perspective. He's paying transit fees relatively small. Once he gets to the leaf nodes, it's the leaf nodes that are exchanging the traffic among themselves. So at this point, usually Vince Fuller stands up and says, yeah, Bill, you're not doing any magic here. You're just shifting the cost from the video service provider to the last mile guys. And that's absolutely accurate. It's also interesting in talking about this with a guy named David Sheridan. He's a professor at Stanford. He got red-faced, upset about this. He says, Bill, you can't possibly be promoting this peer-to-peer stuff. It's never going to work. You cannot come to me and tell me that there's a business model where the cable companies are going to put more money into this infrastructure just so it can be used up by all these freeloader peer-to-peer guys with no possible chance of getting incremental revenue from it. That business model won't scale, and you're doing a disservice by even talking about this thing. It's nonsense. And I do have a citable data source from the research and talking to enough folks about this that almost all North American cable companies do in fact deploy sandvine or other deep packet inspection technologies to throttle back the peer-to-peer stuff. Not down to zero, but they tell me it went from, with the short pipe up, being 80% utilized down to the short pipe up being about 30 or so % utilized by peer-to-peer traffic. It's also interesting to note that the Europeans, some of them have taken the opposite approach, where the ISPs in the last mile have actually put in place their own machines that act as clients that provide seeds for their customer base, so that traffic doesn't go up through the transit providers that cost them money, that they can serve it all locally. So that was an interesting dichotomy. But to have somebody get so red-faced upset was fascinating to me. So again, with the peer-to-peer stuff, to the video service provider, the cost here is a small fraction of a penny. So the bottom line summary slide is this one. What initially I thought would be sort of a typical peering story where you have transit, a CDN, and peering away 25% of your traffic and see what those numbers look like, threw a real curve into the mix here with that peer-to-peer solution end up being such a small fraction of the other distribution mechanisms for video. I'd love to get any of you guys' take on this. We get a couple of questions from the audience. Go ahead, Randy.
Randy Bush, IIJ. Two things is, I remember when we were panicked going from 56K to T1 because all the horrible load we were going to get, et cetera. So I think we've been to similar movies before, speaking of movies. But the second thing is, the real problem with the peer-to-peer stuff, peer-to-peer is killer. Peer-to-peer is what the customer wants. My job is to deliver what the customer wants. It is silly to have a war with the customer over what they want to do. The problem is that the perception between the P2P software developers and the ISPs is a war. If instead the peer-to-peer software developers would make their software localize on my network as much as possible, instead of going to Israel, Germany, and the list you gave, then it's wonderful and works great for me, for the user, and for the distribution system. Try to find the most local source to suck from, not the most remote to get sneaky. And then everybody wins. My job is that they want to use that peer-to-peer technology. My job is to make the customer happy and give them what they want, not fight with them.
But if you're the last mile provider and all that traffic is traversing your infrastructure because it is kept localized, you're going to feel a fair amount of pain. In fact, I remember there was one stat, and I don't know that I cited it in the paper, that said that all it takes is just a few peer-to-peer clients on an area in a cable infrastructure that service maybe 500 customers. Just a few of them will use up 50% of the bandwidth available.
It's what they want and what they're paying for. My job is to deliver the customer what they want. I build the infrastructure to do that and build a business model to charge them for it. Anything else is going to break in some way in the long term.
The last line on this slide is my favorite quote, where Jeff Houston said, "Guys, get over it. Peer-to-peer has won. Telcos and cable companies are trying to keep their 1998 business models relevant. They're clinging on to a model that was built upon static HTML files that were relatively small in size. A small request generated a relatively large response, where large was maybe 20 or 40K. So he would absolutely agree with you. The other interesting thing, Randy, is one of the questions, I presented this at Google, and one of the questions that they asked is, where is that tipping point beyond which video distribution in the peer-to-peer system will not work? Meaning that you'll fill up all the pipes, and you can't do more than 10 terabits per second, or you can't do more than 100 terabits per second. What is that number?
And disk drives will never get bigger than X, right? The big hang-up right now for us all is sitting in the IEEE, who is sitting stalling about 100 gig when they should be looking at a tera and a peta.
Yeah, that's why Steve Feldman said this is a good segue to the next talk. Thank you, Randy. Let's go over here to Len.
I didn't say that. Hi, Len Bosak, XKL. Fellas, the world's different now. First of all, here to Randy. If the customers want something, charge them for it and give them what they want. Don't argue with them. Fighting with your customers is a war we will never win, none of us. So just don't do it. Little hint here. It was convenient for us to light up 110 gig between here and downtown Seattle. We could have lit up 800. No really, run the screwdrivers a little more, no real more hassle. This is not the same world it was a couple of years ago. So don't worry about the leaf bandwidth. We can do it. That's just not going to be the problem. If we get the business model right, we really technically can do this.
That's one of the feedbacks I got from Juniper when I shared the research with them. They said the one thing you're missing, Bill, in the paper is how do people make money at this? You haven't even talked about that, and that's a fair criticism.
The cost per bit per second are going to, the world's different now.
Yep.
Thanks.
Let's do Jake and then Steve.
Okay, so about 10 years ago, we were all worried about Jake Kuhn, InfoSpace. About 10 years ago, we started deploying all these, web caches and things like that, distributed web caching. Do you happen to see sort of a resurgence in caching model for video? And do you take that into account in your models for upstream transit costs?
That's a really interesting question, and I'm starting to think that there may be a trend here where some of the larger content providers that have been outsourcing to CDNs may actually start going to Model 3 in this, where they build out to multiple locations and buy transit in multiple locations and then peer their traffic. And how is that different from them becoming a CDN themselves? And we're starting to see companies like Google and Microsoft and Netflix and YouTube, these kind of guys doing exactly that, actually becoming that caching engine that you're talking about.
And so if that happens, do you think that the providers would actually roll that price back into their transit costs, or do you think that they would absorb it?
Who would absorb information?
The transit providers.
I'm not sure I can answer that question, but I'll share one other observation. Some of the video service providers are really talented at what they do, the encoding and the creation of clients, but they're not as into the internet components as the folks in this room. So they may not be capable or even be persuaded that it makes sense for them to be their own little CDN. They will continually buy from an Akamai and from the transit providers in the room because they just don't see that as their core competence. I'm not sure this is enough to change the price of transit up or down. I remember talking with Quest, who said, Bill, there's no way anybody can make money selling transit for less than $50 a meg. And maybe that's still true, I don't know. But the price seems to be closer to 20 or maybe $10 a meg. Steve.
If people are going to...
Who are you?
I'm sorry, I've forgotten who I am. I'm Steve Bella from Columbia University. If people are going to watch certain content, it doesn't matter where it comes from. If you've got 100 people sucking down 100 megabytes, that's 100 times 100 megabytes, regardless of whether it comes from their neighbors, Singapore, or the original server. That amount of that number of bytes is going to be delivered to their machines. Similarly, that means that by simple input-output model, it means it's coming into your network. Peer-to-peer changes where it comes into your network, and that affects your deployment. And that might be a good thing or it might be a bad thing depending on who you are. The only way to get away from that is something like a multicast model. Now, multicast doesn't work if it's video on demand, certainly doesn't work for asynchronous, but gee, disk drives and the electronics to control it is really cheap too. The moral equivalent of the set-top box. I will spool out Desperate Housewives at 4 a.m., and if you want to watch it, fine. Use a TiVo-like predictive model to see who wants to receive it. But this is the way to get away from it. There's the engineering thing of trying to localize it. I don't know the economics of long-haul bandwidth versus local bandwidth. It's not only a matter of pure economics, it's a matter of who's paying. But if you don't go to multicast, it's coming into your network from someplace, it's going out to someplace. And that's what it may be cheaper to do it locally, it may not. It depends on who pays.
I'll share with you one data point from some of the folks I was talking with on this modeling. Some of these guys actually do multicast within their cloud to get copies of content distributed to all the leaf nodes that they have to then distribute further from. But it seems like we do have some border issues where multicast is not passed or peered. If we want to go down that multicast path, it may be the right avenue, but we have a lot of education and a lot of evangelizing to do to go down there.
And multicast over point-to-point links doesn't buy you anything. Multicast buys you something over a multicast medium like Ethernet. There's no magic here. You can pay me now or pay me later. Just who do you want to pay and when?
Thanks for that. Patrick?
Hi, Patrick Gilmore from Akamai. Two questions. First of all, I'd like to echo what Randy said. It sounds cool to say, let's put it at the leaf, but if one leaf is on one tree and another leaf is on another tree, that's not actually useful. And some of the P2P software tries to localize, but first of all, you don't know if there's actually a local content cache, and second of all, even if there is, you don't know if you can get bandwidth out of it, which leads to the second point. Most of the broadband that I see in the world, not just in the US, but actually lots of places, is asymmetrical. Upload is not equal to download. So if you have 40 million people that want to watch the same thing at the same time, there's actually not enough bandwidth to get it out from the caches to the leaf nodes. And so I asked you this before, actually, and I'm wondering if you come up with any data to show that when you scale this very large, when there's a flash event, as some people like to call it,
Right.
even if I hate that word, if you have an instantaneous event, whether it's Desperate Housewives or some news event or anything else, is there any research to show that a P2P network can actually fill the pipes fast enough, given that it's got to seed the caches and the caches have to re-upload to the rest of the leaf nodes?
Yeah, is Jeffrey Payne in the room? Jeffrey, are you here? No? One of the most innovative companies, and by the way, the peer-to-peer folks are incredibly innovative in this video space. And the reason is it costs them practically nothing to do this. These guys come to me and say, Bill, you talk about $1.2 million per month. I can't afford $1,200 a month. I mean, we need to have a way of distributing videos that don't cost anywhere close to the numbers you're talking about with your large load model. So it should not be surprising that we have hundreds, if not thousands, of these peer-to-peer companies innovating to solve this particular problem. Grid Networks is one that was launched by Jeffrey Payne from Real Network. And these guys are doing some pretty impressive things. They go to the studios and say, we want to do peer-to-peer for the single center, which is your content, out to all these leaf nodes. The clients download these people download these clients to their PCs. And we do, he says, a slow bleed. So let's say 8 p.m., you want to do a Survivor reunion show over the internet. The slow bleed will get that data going out to those clients at 3 in the afternoon. That slow flow out to those leaf nodes will finish up maybe around 8 o'clock or maybe before then. So when you turn on your PC at 8 o'clock and want to watch this thing, it's pulling all those pieces from the neighborhood clients. So it is keeping that information local, and it is available for that spot event. The alternative is going to a single source at 8 o'clock at night where you have maybe 10 million simultaneous streams of exactly the same content filling up and hitting bottlenecks along the path.
Right, but that doesn't work for things that you cannot pre-record, sporting events, news events, etc.
So for live sporting events, that's a question. I don't know the answer to that question.
Okay, and lastly, I'd still like to point out that the reason these guys can do it for $60 a month and deliver 10 gigabits is because they're essentially letting somebody else pay for the equipment, the bandwidth, the engineering time, etc. Now, maybe that's a good idea for Randy to pay for it instead of me, but I'm not sure that everyone in the world agrees with that.
Yeah, David Sheridan says, what you're talking about, Bill, is where do you cache the content? Do you cache the content at the source? Do you cache the content at the exchange points? Do you cache the content at the leaf nodes with the peer-to-peer system? And I thought that was a pretty fair description of it. How are we doing on time?
We are actually about 5 minutes over, so what I'd like to do is, there are 3 people in line. We'll take their questions quickly and then move on. And if your questions that might be more applicable toward the 40 versus 100 gig thing, you might want to defer them until then.
Okay. Who's next?
Tom Watkins with Intellis. I was interested in the multicast they were stating. It seems to me that the largest problem in delivering this video content is not delivering it at the same time. Does people, the market's evolved. People want to watch video when they want to watch video, and a multicast distribution of this stuff, how's that going to work? Because if I want to watch it at 4 o'clock, but the stream was being pushed at 2 o'clock, what is that bias? The peer-to-peer model is people are downloading this stuff and watching it whenever they want to.
Yeah, it's a good point.
So what does the multicast bias at this point if we all peer to multicast with each other?
It sounds like a good conversation for the hallway. Go ahead, Igor.
Hey, Igor with Yahoo. I'd like to comment on a couple of questions that were brought up. First of all, peer-to-peer just simply doesn't work for flash events. The next time Anna Nicole Smith, something happens to somebody like that, and all of a sudden there's 60 gigs of traffic on your network because everybody's watching the videos, you just can't see that. The other issue that Steve brought up was multicast. Until there's real IGMPv3 deployed on CPEs, so we can support SSM, it's not a reality. When SSM is out, awesome. So for anybody who works for a device manufacturer for CPEs, please enable IGMPv3, and the world will be happy because us content providers would love to do multicast.
MLDB2.
Yeah, but until you start supporting, giving us the capability for SSM, it's not going to happen. And to get back to the question of what do you do about multicast with the on-demand stuff, there are ways of doing it. It doesn't need to be one stream that starts at 2 o'clock. It could be a stream that starts at 2:01, 2:02, 2:03, 2:04, etc. And it may be 10,000 streams, but guess what? When you have 50,000 people watching it, big deal. And if you didn't want it, you didn't subscribe to it. So there are ways. Multicast is quite possibly the solution when the CPEs catch up. So.
Okay, we have one last question, and Richard, could you and your panelists start making your way up here?
Hi, Bill. Phil Messer from Amazon. There was sort of a throwaway comment that you made about European ISPs actually distributing local cache servers so they could avoid transit payment. I would love to hear, either in the hallway or if you have any more thoughts about how actually that's working. And is it a model that actually makes any sense with the current peer-to-peer technologies that are out there? Are they randomly picking their leaf nodes, so having the local caching doesn't work very well, or what sort of hit rates they're getting and what sort of transit they're saving on that?
Absolutely. Let's talk offline. The one quick data point I can share, though, is my European friends tell me they use eDonkey, and they can download a movie, and it takes maybe an hour, hour and a half. When I've played around with this stuff here in the U.S., it might take a week. And I think a lot of that is the throttling back that so many of the last mile guys do for the content. I have a handful of paper copies of this white paper that have all the slides and the data and the citations. If any of you guys would like a copy, you can send me email, and I'd be glad to email you a copy as well. And with that, thank you.
Thank you, Bill.